Good evening. This is the 9.2 video introduction to circles. I'm going to be straight into the point. Arid people do not like my jokes from Miss Seitz's class, so we're just going to start right out, jump right into this. We're going to be talking about important formulas you're going to need to know, and the first thing is going to be circumference. Circumference formula, you remember it is 2 pi r. When you have a certain circumference, and we have a picture off to the side, what does r stand for? R stands for equaling the radius. Radius is the length from the center to the edge. That's what we would call r. And in this example, we're going to call it 6. So if I want to find the circumference, what do? I do 2 times pi times 6. I want the answer left in terms of pi. So 2 times 6, that's 12 pi. We always have some type of units, so we'll leave it as that. Area formula is not 2 pi r. It is pi r squared. Right? Knowing that, same idea, r still stands for radius. So if we want the area, we're going to get pi times 6 squared. Well, 6 times 6 is 36 pi. And now units in this one are squared. So I memorized the formula of the r squared is because the units are squared when you do area. And that's for anything. Area of quadrilateral, pentagon, and such, area is always squared. Continuing on, if we want the measure of arc AB, so an arc is from the edge, on the edge of the circle from point to point. So let's say this is AB, and we want the measure of that arc. So that's usually referred to as M with the little MAB with it. So the arc is on top of it. Knowing that, what do? Is that if the central angle equals, let's say it's 60 here, that means the measure of this arc is 60 degrees. So the measure of AB, so the measure is the measure of the central angle. Okay. To find the area of the sector, you need to know the area formula. Okay, because so here it's a sector, it's a piece of it. So we want to find just the piece of the circle. Being able to do that, you're going to interpret the area formulas, but we only want a certain part of it. So what I would do is I would find the area of the whole figure. So find the area, which is pi r squared. And then you'd be multiplying by the percentage of the circle you want. So what do you want? You want the central angle over 360. That's going to give you the percentage of this. Well, what do I mean? Well, first off, if we want the area of this sector here, okay, we need a radius. So the radius is still 6 from above. We know that this angle is how many degrees? 90. So the measure of this arc is 90 degrees. So we're able to say that the area of the whole circle is pi times 6 squared. Okay. What we want, though, is we don't want the whole circle. We only want a piece of it. And in this case, it's 90 out of 360. Okay? Well, what is 90 out of 360? That's 1/4. So we have 36 pi, and we want 1/4 of that, giving me a grand total of 9 pi units squared. Okay, I don't memorize this formula. What I do is I know I have the area formula memorized, and I take the area and then I multiply it by the percentage of what I want. Doing the same thing, what do I know? Now I can find the length. See, measure and length are two different things. Length is actually a distance from one spot to the other, where the measure is just tell me how many degrees. So we'll do the same thing as what we just did up here. So we want the length of this piece. We know the radius is 6, and then it's still a right angle in the center. So length is circumference. So we got 2 pi r, and we're going to be multiplying by the piece that we want. So that's the central angle over 360. Like I said, don't memorize it. Be able to say, okay, what I want the length. So I'm going to be able to say I need 2 times pi times r, which is 6, and then I'm going to be multiplying by the percentage. In this case, it's 90 over 360. So I have 12 pi times 1/4, giving me a final answer of 3 pi units for it. So anytime you want a length or an area of a sector, you need to be having the percentage of what you are looking at. So it's the central angle over 360 gives you that piece. Okay, remembering measure and length are two different things. Measure is looking here, measure, and length is something totally different. All right, last thing that you need to know is inscribed angle. An inscribed angle is an angle that is drawn inside of the circle that touches across the circle and then back to the arc. The measure of an inscribed angle is proportional to the length of the arc. So the measure of an inscribed angle is always half the measure of the arc it opens to. So in this case, if the arc was 60, so the measure of the arc is 60 from A to B, we know that the angle here is going to be 30 degrees. Vice versa, if you knew an inscribed angle and you said if the inscribed angle was 50, how much is the measure of here? All right, what you're going to do is, you know that this has to be twice as big, so you're going to take the 50 times 2 and get 100. And we'll get into that when we get into circles more often. So in the example, what we just kind of did here, circumference, area is 6 for that. So the circumference, what do we have? We have 2 pi r, giving me 2 times pi times 6, 12 pi. That's area, pi r squared. What do we have? Pi times 6 squared, 36 pi units squared. Third one, measure of arc AB. Well, the measure is the central angle, so the central angle is 90, so the measure is 90 degrees. Length, we need the circumference, which we know is 2 times pi times 6. We're going to be multiplying by the central angle that we have over 360. Final answer, 3 pi. Sector, the shaded part. So what do we have? We have the pi r squared, pi times 6 squared, times the 90 over 360. So we end with 36 times 1/4, 9 pi units squared. And then last but not least, we want the measure of ACB. Well, what kind of angle is ACB? It's an inscribed angle because it's on the circle, touching the circle, going across from it. So the measure of the arc here is 90 degrees. So the measure of that angle is half of it, so it ends up being 45 degrees. Please make sure you put the degree symbol there. Moving on, let's finish this up a little bit more. So what do we notice? We notice that the central angle is 60. We want the measure of ABC. Well, what kind of angle is ABC? ABC is an inscribed angle. We know inscribed angles are half of the arc it opens to, but we don't know what the arc is, but we do because the central angle is 60. So the measure of arc AC is 60, which helps us answer that question. Meaning that the inscribed angle opens up to that. So what do? We get 30 degrees for the inscribed angle because it's half of the 60, equaling the 30. In question 3 here, we want to find where O is. O is the center of the circle. We talked about this before, that the diameter is the longest chord in the circle. So we see that this is a diameter. This is a radius, this is a radius. Well, what do you know about all radii in a circle? They're congruent. So where is this located in compared to this point and this point? you said in the middle, that is correct. So what would we do? Well, we said it was in the middle, so we're going to be using the midpoint formula. Remembering it's x1 plus x2 over 2, comma, y1 plus y2 over 2. Let's fill it in. 4 plus negative 3 over 2, comma, 5 plus negative 6 over 2. All right, so what do we get here? We get a negative, or we get 1 over 2. And here we end up with a negative 1 over 2. So that's where the center of that circle would be. Example 4, almost finished now. Example 4, center, we want to find this point here. So using the same idea, but now we're going to be using the same formula. But instead of finding the middle, what we're going to be finding is we're going to be finding the other endpoint. So like some of you like doing this one, some of you don't. Still haven't figured it out. It's not going away. It is still here. So one of the x's, these are the x and y. This is the missing x and y, and this is the middle x and the middle y. So we have 6 plus x over 2 equaling my middle of 4. And we got 11 plus y over 2 equaling my middle of 7. Remember, multiplying by 2 to get rid of it. 6 plus x equals 8. Minus 6 over x equals 2. Multiply by 2. 11 plus y equals 14. Minus 11. Y equals 3. So C is located at the point 2, comma 3. Hanging in there? Hopefully. We're finishing it up here with example 5. Okay, so what do we know? We know Rx, so we know this whole arc here, R to X, is 100 degrees. And we know NR, which looks like it's the diameter, because P is the center of the circle. So it looks like the diameter equals 4. So that means the radius is 2 here, and a length of 2 there. So that's the radius. We want to find the arc measure of the RQ. Well, RQ is right here. It goes from here to here. Well, it opens up. Here's a central angle of 40. So how much is the measure of that arc? It's going to be 40. If we want the length of that, now that's different. We need to know what the measure is. But it's going to be that measure over 360. But we need length, so we need circumference. In this case, it's 2 times pi times a radius of 2. Okay? So what do we end with? We end with that this is 4 pi. We figured out that 40 over 360 is the 1/9. 1/9 times 4. Well, 4 doesn't go in there nicely, so we're going to do 4 pi over 9 units. We want the area of the sector PRQ, so we got PRQ. We want the area of this sector. Well, what do we know? Well, we know it's still going to be 40 over 360, which is 1/9. And now we need to get pi r squared, which is 2 squared. So what do we have? We have 2 squared. So we got 1/9 times 2 squared, which is 4 pi. Which, by coincidence, check that out, the area of the sector is the same. Weird. That'd be great always, sometimes, never question. Bing! Think about it. And last, we want angle POX. POX is what kind of angle? It's right here. It's on the circle. So this is an inscribed, so we got to think halvesies. All right. Well, it opens up to what arc? It opens up to this arc right here, which we do not know the measure of. But wait a second. If this piece is 40 and this measure is a hundo, This piece right here ends up being 60 because I did 100 minus 40, giving me 60. It's an inscribed angle, so you take half of 60, giving you answer of 30 degrees. All right, good luck to you. We'll see you tomorrow in class.